Hello everybody, and welcome to the second presentation in the overall ETSI Mech workshop. So my name is Walter Featherstone. I'm very happy to have the opportunity to present to you all today. As background, I'm Vice Chair of the ETSI Multi-Access Edge Computing Industry Specification Group, generally shortened simply to ETSI Mech. I'm also Chair of the Deployment and Ecosystem Development Working Group within ETSI Mech, otherwise known as DECODE. My aim is to provide an update on the working group's current activities, where I'll try and pick out aspects not covered by the other presentations in the workshop. The DECODE group was formed in December 2018 and was motivated to address application developer engagement, showcasing of Mech, operator adoption. In the following slides, I'll highlight just how active the group has been since its inception. In this first slide, I've listed some of the key activities the DECODE group is responsible for. These include production of OpenAPI representations for the APIs specified by ETSI Mech, API interoperability and conformance test suites, testing focused Mech plug tests covering conformance and interoperability, the Mech ecosystem wiki page, Mech proof of concepts and deployment trials, the Mech Sandbox for experiencing Mech APIs, Mech hackathons, and collaborations, particularly with open source communities, where I've highlighted Acrano, and most recently the Mech Tech series of video podcasts. I'll go through each of these in more detail in the coming slides. In support of developer engagement, the group creates OpenAPI specification compliant descriptions for all the service APIs specified by the ISG. These comprehensive descriptions inherently include each Mech API information model and its service endpoints. They are both human readable and, perhaps most importantly, are machine readable. This enables content validation and also auto creation of communication stubs for both client and server, which is highly powerful when commencing application development. The latest news is that a new specialist task force has been formed with ETSI board approval to further develop the OpenAPI descriptions. This includes updating the existing descriptions to the latest version of the OpenAPI specification and providing new descriptions for those APIs that have recently been developed and published by ETSI Mech. Looking in more detail, the ETSI Forge landing page should be your first port of call for accessing the Mech OpenAPI descriptions, as shown on the right-hand side of the slide. The URL is provided at the bottom of the slide, noting that the site is open to the public, as are the ETSI Mech repositories. On the page, the Mech-specific tab can be seen, along with the currently available service API descriptions. One point of note is that the OpenAPI specification is part of the OpenAPI initiative and is completely independent from ETSI. As an example, I'd now like to talk about a specific representation of one of the Mech service APIs. For this, I've chosen the Radio Network Information Service repository, ETSI Mech 12 ARNIS. This API provides access to a rich set of real-time contextual information relating to a 3GPP access network and the UIs connected to that, i.e. mobile phones, and information relating to their radio network connection. Looking in the ARNIS repository, shown on the left, the various description files can be seen. These are provided in both YAML and JSON, where I'd consider YAML more human readable and more compact. In fact, the JSON is actually generated from the YAML. In the case of ARNIS, a proto file is provided as an example of an alternative transport, where JSON serialization over HTTP is the default. In addition to the description files themselves, links are provided which utilize those files to present the API information in a more interactive manner. First is a link to the Swagger UI, and then secondly to the Swagger editor. So clicking Navigate the API in the browser link brings up the Swagger UI, which will be populated with the ARNIS OpenAPI description from the repository. Through this, we get a much clearer picture of the API's resource endpoints and methods that can be applied to those. This provides a great way to start exploring the capabilities of the API. The Get PLMN information is an example that can be used to query the public land mobile network information associated with an application instance, i.e. its mobile network identity information. To facilitate testing, the group has developed and published a test framework in specification Mech 25. This has been used as the basis to develop API conformance specifications with associated test suites. Like the OpenAPI-based descriptions, the test suites are publicly available and accessible via Etsy Forge repositories. The suites have been developed in both TTCN3 and the Robot framework to cater for both the telecommunication and IT communities. To avoid any ambiguity on the use of the test suites, license and copyright details are provided with each repository. Specifically, the BSD3 clause license, which was felt by Etsy to be suitably unrestrictive to not dissuade application developers whilst providing clear conditions of use. This is the same license as provided for the OpenAPI descriptions. By accessing Etsy Forge, the full range of test suites can be explored. The latest testing-related news is that a new work item on interoperability testing has been initiated within the group, Mech 42. Although this is a new work item, the specification is being built on top of the existing test plan that has been successfully used in the previous plug tests, and therefore the current draft already has a significant degree of maturity. Etsy plug tests have been another area of success, where Mech is now a joint headliner with NFV at the biennial event that's run by the Etsy Centre for Testing and Interoperability. Both interoperability testing and API conformance testing are in scope. The events have proved an excellent opportunity for solution providers to test their Mech implementations in a friendly environment with multiple product offerings. It should be noted that participation at the plug test events are free of charge and open to all, i.e. not just to Etsy members. To enable remote participation, the hub for interoperability and validation at Etsy, known as Hive, has been key. This network securely interconnects participants' remote labs and functions under test. This allows for remote multi-party interoperability testing and validation activities. Integrated with Hive is the test automation platform known as Hive Tap. This acts as a generic orchestrator which is able to transparently execute test suites that are implemented with different frameworks and tailored for different technologies. Noting again that the Mech test suites are made available in both TTCN3 and the Robot framework. Plug tests are very well aligned with DECODE's objective to enable operator adoption by providing a means to demonstrate interoperability between different Mech implementations. They have also proved an extremely useful vehicle for gaining feedback on both the Mech specifications and the OpenAPI representations of those specifications. The feedback has then been used to enhance the specifications and the OpenAPI representations. With the NFV and Mech interoperability plug tests events having just completed last month, a dedicated report will shortly be available. The report related to the API conformance plug tests that was held remotely at the start of the year is already available for download. Here it's highlighted that over 30 organisations and 5 open source communities contributed to the event, providing network functions, virtual network function managers, network function virtualization orchestrators, Mech platforms and services, test environments, test tools and technical support. In addition, a total of 16 remote locations participated to the plug tests, each leveraging the Hive network to make their functions under tests and test environments available for the test sessions. Looking to the future, plug tests are already in planning for 2022 and will have an expanded scope based on the further specification development in the ISG, covering both the further API development and the associated expansion of the test specifications and suite. Another highlight includes the showcasing of Mech solutions that are available in the public domain, where those are listed on the Mech ecosystem wiki. To be more specific, those are implementations that have adopted a selection of the Etsy Mech specified APIs and/or are aligned to the Etsy Mech reference architecture, where it should be highlighted that the reference architecture is just that, a reference, and it is rather the APIs that are considered most critical. There are currently 13 Mech-based solutions listed, each with a link to the publicly accessible web page. Please note that Etsy does not make statements of compliance with regard to the listed implementations. However, Mech applications and Mech solutions listed on the page have been recognized by the ISG as having relevance to parts of the Mech system, or more generally to the overall Mech system. What's been extremely encouraging is that the group continues to receive applications for further solutions to be added to the wiki. Two examples include Eclipse Fog 05, which is stated as providing a decentralized infrastructure for providing and managing compute, storage, communication, and input-output resources available anywhere across a network. It's stated that it can be used to deploy Mech applications on a centralized or distributed Mech platforms. Also, Simu 5G, which is stated as an open source simulator for the data plane of 5G networks that integrates an ETSI compliant implementation of the Mech system. The Mech related communication is stated as being compliant with that standardized by Mech. The Mech services gather network related information such as UE location and radio network information from the simulated underlying 5G network. The simulator also offers real-time testing of third-party Mech apps. These are just two examples where I'd encourage you to take a look at the wiki for more information on all the 13 Mech-based open source solutions. Early on, it was recognized within ETSI Mech how important proof of concepts are in demonstrating the viability of new technologies as that technology develops, and even in the pre-standardization phase. Therefore, to support the development of proof of concepts, Mech specified a framework to support the coordination and promotion of multi-vendor projects targeted at illustrating the key aspects of Mech technology. Specifically, the main objectives of the framework are to ensure that the POC projects are scoped around relevant topics for ETSI Mech, particularly those that is deemed to require input from the field, to ensure the POC results, lessons learned and identified gaps are fed back to Mech, to build confidence on the viability of the Mech technology, to encourage the development of a diverse and open ecosystem by fostering the integration of components from different players, and to support standardization and industry promotion of the activities of the ISG. The ETSI Mech Pop Framework group specification describes the full activities, roles, responsibilities and acceptance criteria. The accepted POCs are then listed on the dedicated wiki page where further details on each of the 13 POCs can be found. Further POCs are most welcome. As highlighted in the previous slide, POCs are a useful tool in demonstrating technology viability. With a significant number of the POCs having been completed, it's clear that the basic principles behind Mech are sound and the core architecture has reached critical maturity. Therefore, to take POCs to the next level, the concept of Mech deployment trials has been developed, the so-called MDTs. Here the focus is to demonstrate the viability of Mech in commercial deployments, rather than as the more typically standalone lab-based POCs. To maintain consistency, the MDT framework follows the same basic process as for the POCs, describing the process and criteria that an MDT demonstration must adhere to. Also, like POCs, an MDT team must consist of at least two different stakeholder groups that include network operator, infrastructure provider, and content or application provider. To date, there have been 6 MDTs, with the last 2 proposed earlier this year. The first of those focusing on enabling smart factory through Mech, and the second considering an edge hub to federate between Mech systems, which is highly relevant to the ongoing specification work regarding Mech federation. Further details on all the MDTs can be found on the wiki page, and further submission proposals are encouraged. One of the most exciting developments since the creation of the DECODE working group is the development of the Mech specific sandbox. This is an online, publicly accessible Mech Service API emulator. This provides an even more interactive means to explore the APIs and receive emulated data based on the selected scenario. In fact, the sandbox was the key enabler for the most recent Mech hackathon, where teams competed to showcase their novel solutions in the emulated Mech-enabled network. The sandbox already has support for multiple Mech points of presence and mobility support with both stationary and vehicular users. Further development is planned for 2022, which is expected to focus on support for V2X related scenarios. I'd love to talk more about the sandbox, but this will be covered in far greater detail in Debashish's talk, which is coming up shortly as part of the Mech workshop. Again covered by Debashish's talk Organising and supporting Mech hackathons has been identified as a key means to engage with the application developer community. After all, making applications and services available to end users from the edge is the key motivator for Mech, and the developers are key in making compelling applications that can exploit the unique capabilities of the edge. The latest hackathon has just completed, which Debashish will cover in more detail. Here it's worth noting that the creation of the Mech Sandbox was triggered from developer feedback from the early hackathon events, and therefore I look forward to hearing more about the feedback from this year's event. Collaborations, particularly with the open source communities, is something that Jane will cover in more detail in the next presentation in the Mech workshop. However, I wanted to highlight that this is an active area of engagement within the DECODE working group. Here we've had particular success with the Acrino community. This falls under the LF Edge project that aims to build an open source framework for the edge. Acrino comprises a set of open infrastructures and application blueprints for the edge. The community has made available an API portal which highlights the key APIs and the Acrino blueprints utilizing those. As can be seen from the figure, a number of the Mech specified APIs appear here. Equally, a number of the Acrino blueprints are listed in the Mech ecosystem wiki that I introduced earlier. As the Acrino blueprints and the Mech APIs continue to develop, the expectation is that further Mech APIs will be presented on the portal. Something I'm excited to announce is the newly released Mech Tech Series video podcasts. These short video clips are primarily targeted towards application developers to provide them with key insights into the Mech specifications and related topics. Each episode is less than 8 minutes long and covers topics such as the adoption of the OpenAPI specification, application enablement through the MP1 interface and associated APIs, and an overall view of the Mech Federation concept. The series is being hosted on the Etsy YouTube channel and has a dedicated playlist. Going forward, the target is to release a new episode every month. Further topics are expected to include Mech Service API development, the Mech Test Framework and associated test suites, further background into the motivation and purpose of the Mech Sandbox, deep dives into each of the Mech Service APIs. The group very much welcomes feedback on those, including suggestions for further episodes and even volunteer presenters on Mech-related topics. So to wrap up, I provided a quick overview of the ongoing activities in DECODE, including provision of OpenAPI descriptions, testing and trials, and the Mech Sandbox. The group holds bi-weekly meetings separately to the ISG on a Thursday, where I hope it's apparent there's quite a different focus. Additional participation in the group is most welcome, as is further collaboration. With that, I'd like to thank you for your attention and hope that you continue to enjoy the rest of the presentations in the Mech workshop.